Hello everyone, today we are performing the experiment to determine the wavelength of helium neon laser light by using diffraction at a single slit. Let me introduce my group members Aditya, agrahari, Abhishek, patel, Ajitesh, myself Aashish Kumar, Aditya, yadav, Abhishek, krishna. We will explain and demonstrate each step of the experiment.
Let us start our experiment by setting up the apparatus. The equipment we are using here include helium neon laser, single slit, graph paper as measuring screen, and ruler and vernier caliper, and a optical bench for accurate measurement.
Experiment aims to determine the wavelength of helium neon laser light using the diffraction phenomena at a single slit. When monochromatic light passes through a narrow slit, it bends around the edges and the diffraction pattern observed on the screen. This pattern consists of central maxima on the right, dark and bright fringes, and on the left side, left dark and bright fringes. The value of the helium neon laser light is 632.8 nanometer.
Now I am going to explaining the observation table of this experiment by understanding the given table of this experiment. The first thing in this table is slit width. What is the slit width? The width of this slit is known as slit width. In this experiment, we are taking the value 0.06 millimeter of the slit width. And the another term is the distance of slit from screen. Distance of slit from this screen is known as distance of slit from screen. In this observation, we are consider it at 60 centimeter. And the another term is distance between first dark fringe, which is denoted as y1 centimeter. I will share you image on the screen, and you must understand the term what is y1. Y1 is the distance between two consecutive dark fringes, and it is considered as 2y1. So when we half of this data, we got y1. So y1 is 0.06 centimeter in this experiment. Similarly, y2 is 1.55 centimeter in this experiment. Similarly, y3 is 2.25 and y4 is 3.1 and then 3.75, and y is mean of all this value in the given table. Y is the mean of all this value in the given table. So it is found at 0.75 and wavelength by using the formula and calculating the wavelength, which is equal to 750 nanometer. Similarly, second observation at 70 centimeter from the screen, and third observation at 80 centimeter from the screen. And the wavelength of helium neon laser is equal to lambda 1 plus lambda 2 plus lambda 3 upon 3, which is the mean wavelength. And when we enter all the values, 750 plus 582 plus 630 upon 3, which is equal to 1463 upon 3, we got 654 nanometer. And the experimental value of this experiment is 632.8. So 654 minus 632.8 upon 632.8 into 100. We got the 3.035 percentage error in this experiment. So the value of error wavelength is 21.909 nanometer, and we use the formula y for lambda 1 is equal to ya upon m into d. M is equal to 1 this experiment, and y we got from here, and a is the slit width and d is the distance of slit from screen. We found every value lambda 1, lambda 2, lambda 3 by calculating this.
We have already seen the apparatus we are going to use in this experiment and the formula and theory which we will use to perform the experiment. Now we will look at the procedure what we are going to follow to perform the experiment. So first of all, we will align this laser light, this slit, and the graph paper which is measuring screen on the optical bench. After that, we will place this graph paper on a specific distance. We will record that distance. After that, we will turn on the laser to observe the diffraction pattern on graph paper. So this one clearly. Here we can clearly saw the diffraction pattern. Now we will mark the central maxima on the graph paper and all the dark fringes we observed here. And after marking this, we will measure the required distance. We will mark the dark fringes which are observed due to diffraction pattern. Now we will measure the distance between the nth dark fringe on the left and the right side of central maximum. So we have marked here 2y1, 2y2 and 2y3. This is the first dark fringe. This is for second dark fringe and this is for third dark fringe. Now using these measurements we will calculate the distance between adjacent dark fringes, and using this measurement we will calculate the wavelength of the helium neon laser.
We are going to start what is the precaution of the experiment. Precaution 1 is we do not look directly on the laser light beam because it can damage our eye. So, and during we have to calculate very carefully the distance between two dark fringes. Otherwise, there is a probability chance that it will occur an error.